In this video, we will discuss the next step of the machine learning pipeline, which is feature selection. Feature selection refers to algorithms or procedures that will allow us to find the best subset of features from all the variables present in our dataset. This is a process to identify the most predictive features. At the beginning of the feature selection process, we start with the entire dataset, with all the variables, and by the end of the feature selection process, we end up with a smaller number of features, which are typically the most predictive ones. But why do we select features to begin with? I couldn't possibly emphasize more the importance of selecting features when the machine learning models that you are building are to be used within a business. First, simpler models are easier to interpret by the consumers of the models. So those people who act on the decisions that the models make will need to understand those decisions. In this sense, models built using 10 features are easier to understand than models built using hundreds of features. Second, shorter training times. It takes less time to train, but more importantly, less time to score if the model uses fewer features. Third, we may achieve enhanced generalization by reducing overfitting if we use less features. Fourth, and particularly important for this course, is that models that are built on smaller datasets, utilizing fewer features, are easier to implement, and by this I mean to fully integrate with the business systems by the software developers. Models built using fewer features are easier to put into production. Why is that? First, we need to ship smaller JSON messages between the business systems and the model. Second, we need to write less code to preprocess those features. And we also need to write less code to handle potential errors. But let's continue with the advantages of feature selection. Utilizing less number of features minimizes the risk that we may encounter due to data errors. And of course, more often than not, data is redundant, which means that many features provide the same information. So why should we use them all when we're building our models? Let's go back to why it is important to deploy models using the less amount of features possible. As I said, we will need to build smaller JSON messages to be sent to and from the model to our other business systems. These JSON messages contains the variables that we need to input into our model, and then they will take the predictions out onto our systems. We also need to write less lines of code for error handling. For example, lines to handle the previously unseen values, as we were discussing in the previous lecture. Typically, we write error handlers for each and every variable we send into our model. If we use less features, also, then we need to log less information to our databases. Typically, when we put our models in production and we write production code, we log all the intermediate steps to have some sense of how the process is working. And of course, the less variables we use, the less code we need to write to engineer those variables. As data scientists, we need to keep this in mind so that we don't build models that will overwhelm our developers and also our business systems. We often find that many of the variables present in our datasets are redundant. So why should we ship them all to our models in the cloud? What do I mean by redundancy? Well, often we find variables that are constant. These are variables that take one and only one value, the same value for all the observations. We also find quasi-constant variables. This is variables that take the same value for the great majority of the observations except for a tiny proportion. These variables tend to be quite useless to make predictions. So we may as well get rid of them. We also find duplications. This is two variables, potentially even with different names, but are otherwise identical in all of their values. And finally, we also find correlation. and correlated variables tend to provide the same information about the target that we want to predict. So there is no need to use the two variables if they are correlated. Including one of them already adds most of the value that can be extracted. There are several ways in which we can select features. I am not going to go into much detail because this is not the scope of this course. But just to give you a flavor, there are three umbrella terms under which we group the different feature selection algorithms. One group corresponds to the embedded methods, another group to the wrapper methods, and then we have as well the filter methods. All of these group of algorithms have advantages and disadvantages. Let's go over them. Let's, for example, think about filter methods. Among the filter methods, we find, for example, simple statistical tests like ANOVA or chi-squared. These methods are independent of the algorithms we intend to build at the end, and they discriminate features based only on the feature's characteristics. Why are these methods good? Well, they often provide a quick first step to remove a big chunk of your features, particularly if you're using big datasets with lots of variables. These methods, filter methods, are model agnostic, so the selected features should be suitable for any one algorithm you want to build. And they are, of course, fast for computation. On the downside, filter methods look at one feature at a time, so they do not capture feature redundancy or feature interaction. And at the end of the day, they tend to provide the lowest model performance. Let's move on to wrapper methods. Wrapper methods do take the algorithm we intend to build into account when selecting the features. And they do not evaluate one feature at a time, they rather evaluate a group of features. Wrapper methods are also known as greedy algorithms because, in theory, they evaluate all possible feature combinations and only then decide which one is the best. There are a few ways in which we can achieve this, but I will not go over them right now. So let me just tell you that the advantages of using wrapper methods are that they consider feature interaction and that they tend to find the best feature combination for a given algorithm. On the downside, they are not model agnostic, which means that the combination of features they found for a certain algorithm may not be the best for a different algorithm. And wrapper methods involve building a different machine learning model for each feature combination, so they are computationally very expensive, to the point that they are often impracticable. So then we come to embedded methods, and they tend to have the sweet of both worlds. Embedded methods refer to those feature selection procedures that co-occur with actually training the machine learning algorithm. The classical example of embedded method is the lasso regression, and also the feature importance that we derive from fitting tree-based algorithms. On the good side, these methods do consider feature interaction and tend to provide a very good model performance. They are faster than wrapper methods and tend to produce models that are more predictive than those based on features selected by filter methods. On the downside, they are not model agnostic, so features selected by random forest, for example, may not be the best to use in a linear model. So what do we do with feature selection and how do we make it part of the pipeline? We can, of course, make feature selection part of the pipeline. But the issue is better resolved if we select the features ahead of building the pipeline that we want to deploy, and then make the list of the selected features part of the pipeline that we want to deploy. And this is what we're going to do in this course. We're not going to make the algorithm to select features part of the pipeline. We're rather going to come up with a list of features that we think that are most important, and we are going to make that list of features part of the pipeline. I will cover more why we think that this is the way forward and what are the advantages and disadvantages of making the feature selection algorithm per se part of the pipeline. See you in the next video, where I will go over building the machine learning models.